This is Sam with Nexus Workshop, and we're going to be talking about the Nexus Ultimate Prop Controller. But today we're actually going to be talking a little more generic. This is going to be some stuff that it's just basic Arduino or escape room electronics stuff, but we're going to specifically talk about it as it pertains to the Nexus Ultimate Prop Controller, which to say, it's not a lot. The prop controller is handling all of the behaviors and all of the code, taking all that away from us, so we're able to do it completely no code in the config UI. That's where we're going to choose what pins we want to assign to be what, or rather, what we're really going to do is we're going to say, I'm going to hook up 3 buttons and a relay, and then it's going to automatically pick pins for us, or let us go back and decide which pins we want to use for that based on the 12 that are available on the controller. Of course, you can also do expanders and stuff like that to get more than 12, but that's what theirs start with. But now we're talking about literally how do I hook it up? And so to do that, we're going to take a look at this. So this is a diagram that I will link in the description here. I'm also just going to have it in our guides and on our website. But this diagram, I went ahead and threw a couple different things on there. On the left side, I have a couple of inputs. I've got a button, I've got a read switch, and I have a force-sensitive resistor, which is it's just a resistor similar to any analog input on the prop controller. The weird thing about it is it only has 2 wires, whereas most, if you take a potentiometer, it's going to have 3 wires, and those 3 wires are a ground, a voltage, and then that middle one is the one that changes the variable resistor between those. With a force-sensitive resistor, it doesn't have that. It just has 2. And so you actually end up having to create that third leg. And we'll talk about that in a second. Over on the right side, we have our output, which right now I just have a relay. I have a relay driving a maglock. On there, I do have a flyback diode, which is an important thing that we're going to talk about. And that, instead of being a maglock, it could be a latch, it could be a light, it could be whatever I want. But the point is I have something that is a relay. It is off, on. So let's start talking about those things. So again, on the left, I've got a button and I've got a read switch. What's different about those from an electrical, how do I sense them thing? Nothing. It's literally 2 pieces of metal, you touch them together. So the button pushes the metal together. The relay is literally 2 pieces of metal, and when the magnet gets there, it sucks it up and makes it touch, and that connects the circuit. So our prop controller is taking a input pin, and it actually pulls it high, and when it gets sucked up, it touches the other thing, it's now routed to ground. So we've got 2 wires coming off of those. We do not care which way they go. They can go either polarity. There's just 2 wires. They're probably not even labeled. They're probably just white wires sticking out the back, or 2 pins with no labeling. And that's where we're going to hook up. We're going to hook 1 pin to ground and 1 pin to our signal input. What signal input pin do we need? Don't know. What did you configure in the controller? So whatever you set up for the prop controller, that's the one you're going to use. On the left side, L9 and L10 are some of the first ones it's going to recommend. So if you just add a button to a prop controller today, that's where it's going to put it. Now those grounds, you notice that I have them up on L1 and 2. And I've got those little jumpers there, just to the right of that, where I have jumpers between the yellow and the black. I have another video talking about this and the jumpers, but those jumpers mean that those screw terminals became ground connections. L1 through 4 and R1 through 4 are available to do this with, because the physical board, when it is on our little terminal breakout port, does not use those pins. It literally is shorter than the number of pins. I have 24 pins down my terminal board. I have 20 pins down my actual controller. So those top 4 are available for you to turn into grounds, to turn into voltage rails, do some fun stuff with. Again, there's another video on that where I go into a little more depth, but I am using that here to make those wires into grounds. So I can connect those and connect my signals on L9 and L10. I've got a button, I've got a read, nothing weird. My force-sensitive resistor. Again, that's going to be treated as an analog input in the prop controller. That's how I'll configure it. But it's got 2 wires. They also don't matter which way they go. But I went in and colored those wires in as red and black because that's kind of a little more what we're kind of thinking of. The red is coming from my 3.3 volt thing. I cover this more in my video on analog inputs, about 5 volt versus 3.3 volt. This board has 5 volt rails, but is a 3.3 volt controller, which means if you connect this resistor up to 5 volt, you will get potentially a different range of readings that wouldn't be complete. So you want to hook it up to 3.3. I have a note here in that text note, L20 on the board is the 3.3 volt pin. So you have that available. Boom, there you go. But I have that coming into one wire on my resistor, and then, on my force sensitive resistor, my pressure pad basically. And then my other wire is going to my input pin. I've got to go into an input pin, and then I have to create a voltage divider circuit. I have to create something that lets the board compare it, because right now it doesn't really know how to read these levels. So basically what I do there is connect a resistor between that signal input pin to my ground. In this case, I know that I have a ground on L22 because that's where I have it on the board. So I've got that little resistor jumping down to that. And that is what I need to do that analog. Over on the right side, I've got my relay. Just like that button is literally two wires attached together, a relay is two wires attached together. It's kind of a reed switch in reverse. There's a little electromagnet inside that blue box. And when it gets its coil circuit charge, it gets voltage applied to it. There's a little EMAG in there that pulls down and makes those wires touch. So on the left side of this board, I have three wires. I have my power, my ground, and my signal. Power and ground is how it literally powers that relay. I'm going to use a 5-volt relay module so that I can power it right off the board. You can see those wires there, my power, my ground, and my signal wire. Power and ground, hey, that thing I talked about earlier, R1 and R2, and I've used little jumpers there to give them my 5-volt rail, that red rail, and my ground rail, that black rail. And I've put that to my yellow rail, which is the actual screw terminals. Again, another video on this. My signal wire, I'm coming off of R13, is what I've configured. I set that up in the prop controller. That's why I use that one. And that is doing my signal. On a lot of relay modules, they'll have another little jumper on them that chooses whether a high signal or a low signal makes it trigger. There's also all sorts of behaviors to whether, like with a mag lock, do I want the relay triggered to be the mag is on, or do I want the relay not triggered to be the mag is on? These are all decisions that you get to make and behaviors you can make and things that the prop controller will kind of lift off of you. You don't need to worry about. But if it's backwards, you can try moving that jumper, or you can just tell it the other command inside the config in your behaviors. That relay then has its outputs. So it usually has 3 wires on the output too. It has what's called a common, a normally open, and a normally closed or normally connected. Normally is the state when the relay is not happening. So there's no charge going to it. It's powered off, whatever. The common and the normally connected are literally touching each other. It is, you can think of it as a wire. It is the wire touching. When the relay gets activated, those stop touching, and the normally open and the common start touching. So it is the same thing as a light switch, as you holding 2 wires and tapping them together. That's what a relay does. So now let's talk about what we want to do with this relay. I've got an EMAG. It gets power and ground. So I have some kind of power supplying to it. I have voltage on my ground. It goes through the EMAG, and the EMAG is magnetic. It's turned on, or a light bulb, or a latch, or whatever it may be. What if I want to turn it off? Well, if I disconnect the positive leg, the red wire, then it's off. And so that's what the relay is literally doing. It is quite literally touching these things together and disconnecting them. So you can see there on my diagram, my red wire is being broken by my relay so that I can reconnect it when I want to. The other weird thing about the EMAG, well, I guess let's talk about that power source. It's coming from a 12-volt power supply. That could be the same power supply that is powering 12-volt to my prop, if that's how I want to wire it. It doesn't have to be, because there's nothing about this side of the relay that's actually electrically connected to that side of the relay. That's what makes relays great. They isolate these things. Whenever I'm building out a full room, I definitely like to have isolated power supplies. So I would have clean power supplies for all of my controllers and things like that. And I would have a dirty power supply that is supplying all the power to my EMAGs, my latches, all of my things that are gnarly and put voltage spikes and are messy and dirty and gross. You don't have to do that, but especially if you're having issues, that's one of the first things I'm going to go to try to troubleshoot. The other thing is this flyback diode. So you see there between the red and black, right before it gets to the EMAG, you want it as close to the EMAG as you can get. You have a diode, a flyback diode. That is going to allow the voltage to sort of dissipate when it gets turned off. Once you have this EMAG, especially the longer it goes, the higher voltage it is, higher current it pulls. When you turn it off, motors, latches, all these things send a sort of voltage spike as all the electrons pile up or whatever's actually scientifically happening behind there. But it sends this sort of reverse current spike that has the ability to make controllers go crazy if it hits them or hurt other electronics. So if you have other things in these circuits, they can potentially hurt it as they're getting kicked by this voltage spike. Putting a flyback diode there prevents that. And it's basically allows it to absorb its own little kick inside of itself because that's the path. On diodes, they have a little line on one side of them, typically, which is the direction that voltage is allowed to pass. If you put that where that voltage is allowed to pass from the positive to the ground, that's a dead short, and it will blow fuses, it will overheat wires, it will melt things, it'll probably blow the diode first as it just pulls way too much current. You do not want to do that. You will notice on my diagram that the line is pointing towards the red. It's actually backwards. So normally, power is not able to flow through this diode. Diodes only let power flow one direction. They let it flow from the non-marked side to the marked side. Because it's backwards, it won't let it flow that way, but instead, when we turn that relay off, that wire is broken, and there's no longer a path there, but there's this voltage that's kind of stuck in the EMAG. It lets it dissipate by going backwards. And it goes backwards inside that magnet itself, absorbs itself, and is nice and pretty. Flyback diodes, they're your friend. Put them in. They're cheap. You can get them in 20 packs, $100 for a couple bucks on Amazon. They're cheap. They're worth it. There you go. Read more on it. I'm not actually an electronics expert. I am a maker. I'm an expert in escape rooms and in designing props and building things and interactive experiences. And I know just enough to know what's important and what I need to focus on. I think I've covered all of the notes that are on this, but if you have any questions about it, feel free to drop them in the comment. Feel free to send us a message, reach out to us. But I just wanted to give this to kind of give you a little quick start on, again, this is literally hooked up to a prop controller, but it could be hooked up to an Arduino or to an ESP32 or to a Raspberry Pi or to anything. This is just really basic electronic stuff as it applies to immersive entertainment, as it applies to escape rooms, as it applies to building little tchotchkes and things that do things, make a thing do a thing.